Hello, everyone. This is Kenneth Bruni. So I'm going to do this recording, and I believe based on the structure we have over here, I thought it's wise to record at least 3 videos. So the first one is going to deal with the model development, and then the second one we are going to look at how we evaluate the model, and then the third one is definitely going to be a deployment of the model as a desktop application. Sorry, as a web application. And obviously, when we meet in class, I'm going to show you how we do it, maybe with a desktop. So at the end of the day, we are going to end up with something like this. Okay, so this is the application, and then we are going to have some input field where we can input maybe sepal length 5, sepal width maybe 3 centimeters, the petal length is maybe 6, and then the petal width is maybe 7. Okay, and then we'll click on predict. So these values will be fed into the model, and then a prediction will be made, and we are going to see everything. So over here, the prediction is iris vesicular, and then these are the class distribution, because you later find out that whatever data you give your system, it should be able to tell you what percentage of, based on the learning that I know, that I think it is belonging to a particular class. Now, this will come in very handy. Let's assume you pick some data. Okay, so for instance, maybe these are some medical records. So maybe this one is temperature, and maybe some other vital things they pick at the hospital. And then you predict a particular disease, maybe COVID or malaria or whichever disease based on the classes that you have. You would want to give the medical experts exactly how you feel about each and every prediction. Because if it is about 46% COVID and then 35% maybe fever or another disease, you are going to be guided in the kind of prescriptions that you make. So these are things that we are going to understand, and we need to present all these facts for the expert to also make a decision. But at the end of the day, the higher value in terms of the percentage is what is going to be predicted as the final thing that we see over here. So we are going to build this application. But before we come to this level, we first of all need to build the model and then do the training and all the things we spoke about in class. So this is the link to my GitHub account. I'll share the link with the course rep so that at least you go through the process. This is what I was trying to download the last time, which the internet wasn't working properly for us. So with today, when you get to github.com/Cambotech, okay, and then you click on repositories, this will definitely lead you to the specific one I want you to download, because that's what we have, the material. And I think the material contains everything that we need to get us working. I'm using the same network I used the other time, so kindly bear with me. All right, so when you get here, when you click on this link, repositories, scroll down. These are some projects I worked on, but then I don't think what we want is anywhere located here, so it's on the next page. So you click on next, and then this is what we need. Okay, so this one, shallow network. So you click on this. Now finally, what I'm going to do is I'm going to share this link with you so that in your case you don't have to go through the process of clicking next. Okay, all that you need to do is just to paste the link over here, and then it will straight away lead you to this page. Now when you get to this page, it's a very simple process. Okay, this is something I recorded and committed about 4 years ago, okay, somewhere 2022. So what I want you to do is you click on this green code link over here, this button, and then you have a zip file which I want you to download. So click on download zip over here. This is basically going to download everything you see over here, and then we are going to work with this. So this has been downloaded. It is going to be in my downloads folder. So I'm going to go through the downloads folder, and then this is what I have over here. So I'll open this up, and then I'll just need to extract this. So I'll click on extract, and then okay. So the extraction is done, and then I can navigate through this. Now open it up until you get to this point, okay, where you are seeing the flowchart image, and then the iris data set we are going to work with is already here. and the other stuff. So you don't have to be finding the data somewhere and stuff like that. Once you have this repository, you are good to go. Now, what I want you to do is to click inside of this URL link and then type in CMD. Okay, so we just want to activate the command prompt window in this particular directory. So when I click on enter, you see that's exactly what we have over here. Okay, now I want to launch Jupyter Notebook over here. So I'll type in Jupyter Notebook. Look, there are several ways of doing this. Okay, people already have Anaconda on their system and stuff like that. You can do your own thing, but then if you want it to be very simple for you, like you've seen me do, just do it this way. So you type in Jupyter and then there's a space and then notebook, then you press enter, and this is going to activate the Jupyter Notebook server in this particular directory for you. Now, talking about Jupyter Notebook, it is definitely one of the libraries, Python libraries, you are going to work with. So if you don't have Jupyter Notebook, what I want you to do is type in CMD. Once again, you open your command prompt window, and then you just do pip install. Then you type in Jupyter Notebook like this, and then you press enter. You need internet for this to work, but I already have it installed, so I don't need to go through the process. Alternatively, or maybe in addition to that, what I'm going to do is I'm going to share these resources, which are definitely on my YouTube channel, for you to also have a second look. Okay, and then these are going to help you navigate through the whole process. So yes, under videos, I think this particular one will do you a lot of good, especially with the Jupyter Notebook environment setup. So I'll share all the links with the course rep. There's a particular video I go through the process of installing that. I don't know, it is somewhere. Okay, it is somewhere, not these ones, but let me see. This yeah, I think this particular video. So how to download and install Jupyter, the how do you call it, the thumbnail is now loading up. Yeah, so this particular video. Okay, so I'll share all these links with the course rep, and then you can just follow through. All right, so we have opened this up, and then what I want to do is I want to, you see there's this net.ipnb file over here. Just double click on this, and then this will open up whatever thing we need. Now it is through this file that we have everything that we are going to work with. Okay, so we are going to build a shallow neural network, and then based on the network, we are going to specify the neurons that we want to get that network. Remember what I spoke about earlier on, that the neurons are the basic building block, they are the processing elements. So some data inputs will come into the neuron, and there will be a summation operation, and some random weights will be automatically generated, and then the multiplication will be done, the summation product, and then an activation function will fire them, and then it goes on and on and on. So for the activities, we are going to develop a machine learning model using a shallow neural network. So the word shallow over here is basically defining the kind of neural network that we are trying to build. So definitely the opposite of shallow is deep. Okay, if something is not shallow, then definitely it is deep. So there's also the concept of deep neural network, which is probably something we are going to look at maybe in class next Monday when we meet. So we are going to use the Iris dataset to train the model. Then we are going to do some performance analysis of the model, and then we are going to use the developed model to make predictions. So this is the flowchart. So we are going to start, and then we are going to load our data. We spoke about this last week. So we are going to do the pre-processing of the data, where we are doing exploratory data analysis, and then we go through a decision where we split the data. So over here we are splitting into the training data and then the testing data. We use the training data to build a model, and then we use the testing data to test the model that we have built. You see the arrows showing the flow of how things are going to be done. And then once the model is tested, we can now make some predictions and then analyze our results, and then we end. So over here I have a few cells that have already opened up, and then some comments over here. So definitely this is going to guide me on what to do. Okay, that's exactly what I was missing the last time. So let's quickly move on. Remember, we already have this iris.csv data over here. This is some data we spoke about last week, so I don't think that will be a problem. Now, what I want to do is I want to create a new notebook file, and this is going to be like where I'm going to do the rough work. Okay, remember last week I was trying to make you understand some basic concepts. Okay, so this is where we are going to do those stuff, so that here becomes a little bit clean. So over here, the instruction is for us to download NumPy, Pandas, Matplotlib, Keras, and then scikit-learn or sklearn. And because this was something I worked with some students in the past, look, you see that this is a Python Pandas tutorial. Okay, they are in two parts, part 1 and then part 2. So if you are interested in some of these things, when you watch this video, you definitely have an in-depth tutorial and understanding of Pandas. So these materials will help you. And then I think there's NumPy. Okay, I think yes. So there's NumPy over here. So NumPy 2, I have 2 videos. So this is Python NumPy tutorial part 1 and then part 2. And these are things I recorded 4 years ago. So they may look old, but then they are still relevant. Very, very important. Now, if you are doing this for the first time, and these are libraries that you don't have, you still have to go through your command prompt. So you do cmd, and then you do pip install NumPy. Okay, and then you can do pip install pandas this way, and then pip install scikit-learn and Keras and all those things. Okay, so these are libraries that you first of all need to install before you can go through this. But the assumption is you already have them installed. So now let's work on it. So I'm going to import them. So I'm going to type import. The first one I want is NumPy as np. We spoke about why we are using this, because this then becomes an alias that we can use. So instead of typing NumPy all the time, we are basically going to type np. The next one that I want to import is my pandas. So I'm going to say import pandas as pd. And then I'm going to do, this time around, this is matplotlib. Okay, this is what we are going to use for the plotting. Okay, so I'm going to say from matplotlib, that's a matplot library, import pyplot as plt. Okay, and then I want to import Keras, which I'm not going to use maybe now, but then later. And then I also want to import sklearn. So every library is going to play a role. Okay, and NumPy is numerical Python. So this is a library that whenever we have any calculations, we want to work with matrices and stuff like that, we would follow on NumPy to help us. Pandas will also have some data exploratory and other things that we need it for. So if you want to analyze data, want to get some statistical information about data, Pandas is there for us. Matplotlib is going to help us do the plotting. Okay, you want to do visualization and stuff like that, we are going to rely on Matplotlib. Now Keras is from TensorFlow. Okay, and this is where we are going to get the libraries to actually build the models. Okay, or the artificial neural network model. And scikit-learn, this is arguably one of the biggest machine learning libraries that you should know. Okay, so this will have all the algorithms you can ever think of. Okay, so whether it is regression or classification or clustering, all the algorithms you've ever heard of, KNN, how do you call it, PCA, I mean all the other ones. Okay, K nearest neighbor. Okay, so that's KNN, and all the algorithms you can ever think of, they are all located here. Okay, all right. So we want to import our data set. So I'm going to have an object called data, and then I'm going to use pd, which is a panda. So I'm going to do pd.read underscore csv, and then I type in the name of the data, which is iris.csv. Remember last week we spoke about this iris data set. So once I have this, I'll click on shift and then enter, and we have a problem over here. It says PD is not defined, and that's simply because I didn't run the first cell that I have imported over here. So I need to first of all run this. So I'll do a shift enter, and then when you are running this for the first time, especially when you are loading the libraries, it takes a while. Okay, so you need to wait for this star, as you see over here, to now change into a number, and then you know that okay, everything is okay, you can move on. So you wait a while, maybe in a few seconds it will be done. So we can see that that is done. So we see 2 over here, and 2 is showing up because we had already run this, and then this was taking the first position. So now that everything is loaded, I can now do a shift enter, and then now I have the cell loaded and everything is looking good. So what I'm going to do is I'm going to create in some new cells beneath here to do a preview of the data. So when I just do data, okay, this is almost like print the data that I've imported using the .read CSV method inside of pandas. So when I run this is what we saw. And from the last time we met, which wasn't last week, Monday, we saw that we had the ID, the sepal length CM, the sepal width CM, the petal length CM, the petal width CM, and then the species. Okay, we spoke about whatever thing is happening, but let me also spend time to explain a few things for the benefit of those who couldn't join us last week. What is happening here is I need something to be writing some notes. Okay, so what is happening here is we have this data that we are working with. Okay, and we said for us to build AI stuff, we first of all need to go through the process of training a model, and that model will be deployed to be doing the magic, to be thinking like a human being, to be making predictions basically. So what is happening here is we have the data, and what is this data about? This data is about flowers. Okay, so a man called Fisher decided to conduct an experiment where he was just gathering data of these flowers, and they are all iris flower. Okay, but then he realized that there are 3 different categories or 3 different variations, and the differences between variant 1 and variant 2 and variant 3 had to do with the measurement of the sepal, that's the length and the width of the sepal, as well as the petal length and then the petal width. So he did those data collection, and then he submitted them, and people have been using it for at least some elementary data analysis work. So what is happening over here is we have this data. Now the first column we see over here is the ID column, and this ID column is just basically telling us or giving us a chronological order in which the data was inputted. So for instance, this is the first row, this is the second row, third row, and stuff like that. We do not necessarily need the ID column for any kind of work that we are going to do, but then we are interested in the sepal length. Okay, we are also interested in the sepal width, we are interested in the petal length, the petal width, and then the species. Now what we know, okay, based on the data that we have over here, is the fact that when he collected the data, for instance, when he measured one particular flower, he got maybe 5.1 centimeters for the sepal length, and he recorded it. That same flower, when he measured the sepal width, he got 3.5, and then went on to measure the petal length, he got this, and then petal width, he got this. Now at this point, somebody may be asking, what exactly are the petals and the sepals of the flower? Look, it is very simple. Now, petals and sepals of a flower, and this we will definitely see in integrated science and stuff like that. So typically, let me just zoom in on this one. So typically, the petals are like where the colors are bright. Okay, so sometimes they are yellow, they are red, stuff like that. So these were the length he was measuring. So the width would be like maybe from this part, okay, to this part. Let me use a different color. Let me use black. So maybe from this, oh, what is happening? Okay, let me clear everything. And then, so from this part to this part is going to be the width, okay? and then the sepal length is going to be from the tip to maybe at the bottom here. So that's what he was measuring. And then the sepals are going to be the lively green base, okay? So the sepal width was from here to here, and then the length, which is definitely going to be the longer part, will be from here to here. So these were the measurements he took. So maybe this particular first flower, he got this measurement, he measured it and then put it in some book or some record, okay? So that's what we are seeing over here. And through his observation, he got to know that, look, there are a lot of them. So there were 3 main species. Now what we see, the first one we see over here is Iris setosa, okay? And then it gets to a particular point and then it is truncated, and then we see the last. So what is happening over here, when I just do a preview of the data, no matter how big or small the data is, it's going to preview or show me the first 5 rows, okay, the first 5, and then it will truncate it and then show me the last 5. That's what we see over here. But what we then see here also gives us some kind of idea of what is happening. So over here it tells us that we have 150 rows by 6 columns. At least for the columns we can count, because that's what we see over here. So the ID is part of the column. So we have 1, 2, 3, 4, 5, 6. These are the columns, and the rows are the horizontal cross section. So when we count down, we are going to get 150 of them. All right. Now what is happening is if I want to preview data, maybe I want to go beyond the first 5 rows and the second 5 rows. Look, if I'm to do data.head, and this is basically things that pandas will give us. If I do data.head, this is basically going to preview, at least when we say the head of something, that means at the very top, okay? So this is going to give me the first 5. Okay, so this is the first 5, and we can actually verify them using their ID numbers. So this is number 1, number 2, all the way to number 5. The numbers we see over here are basically these are the IDs, okay, or the Python indexing counting numbers. All right, I had a small interaction. I had a call I needed to pick up. So the numbers you see over here are basically from the fact that Python starts its counting from 0. Okay, so naturally it will give you some numbers one way or the other. However, this is what we had in the original data set. Okay, so data.head is giving us the first 5. What about maybe if I want the first 10? Okay, then I need to pass in the value 10 inside of the parentheses. So when I do data.head 10 and I pass in 10 in there and then run this, you see that we get to see the first 10 showing up over here. All right. When I do data.head 20, I get to see the first 20 showing up over here. But look, you cannot do data.head and then maybe passing 50 over there. You are definitely not going to get all the 50. Okay. I think, yes, this one, okay, this one is giving us all the 50, as you can see over here. But then we cannot get, I think we can get 60. So let me do 60 and see. So yes, okay, we get 60. But what I want you to pay attention is when we get to number 50, okay, this is number 50. You see that it was Iris setosa. So the first 50 was Iris setosa. And then from 50, or the second 50 was Iris versicolor, this particular breed, okay? And then the last one, or the last 50, will be the Iris virginica. All right. But we don't necessarily have to go through it one by one, okay? We have other techniques that we can use to verify some of these things. So the data.head is going to give us the first 5. Then what about the last 5? Then if your guess is as good as mine, you can do data.tail. So this is going to give you the last 5. And you can actually verify, because we get the last number over here and then it moves up in that way. So we can confirm that we have the Iris setosa, Iris versicolor, and then Iris virginica. These are the 2 types, or sorry, these are the 3 types of the plants that we have. So we are going through this process. Now, the next thing we need to do is to define the input and output variable. And this is what I had in the notes over here. So over here, we are saying that, look, whatever data that we have, okay, and the columns are going to represent the features. So we need to tell our model which ones are the training or the input features and which ones are the targets. So over here, we get to see that we need to do a split, okay, on the vertical axis. And that's the same thing we are going to do over here. So on this split, we are going to tell our system that, look, everything that has to do with this chunk of the data is what we are going to represent as our X. And anything that has to do with this chunk of the data, let me use a different color. So let me clear this. I think the black is blending in. So let me use red. So we are going to say this is going to be the input side of our data, because that's going to be the X inputs. Because these things will reflect or will have an impact on the kind of the species of the flower. For instance, you could see that just by looking at this, okay, you could see that for Iris virginica, the sepal length, they are quite huge, okay, something like 6.7 centimeters. But in the case of, let me show you, in the case of the Iris setosa, see that the sepal length are not as high as 6.7. So those are the key things we can use to distinguish whatever thing we see over there. So that's going to be the input side of things. So let me just mark them once again. So this is going to be the input, and we are going to call these X, okay? And then we are going to have the output. Let me bring in the green. So the output is going to be what we are going to call Y. Now you could see that when I was dealing with the input and output, I didn't consider the ID column, okay? So the ID column is more or less redundant. It doesn't add anything, okay? It doesn't add anything to the data. It is not giving us any concrete value or any meaningful thing. So we don't want to be adding these IDs. So these are things that we are going to drop from our data sets so that it doesn't have an impact on the data. So with that said, we are going to do that, but I have some important visitors here with me. So I'm going to pause the video and then I'll come back to record. All right, so on the inputs variables, what we are going to do is, first of all, we are going to drop these ones, okay? So I can do data, which is original one, dot drop. There's a method over there called drop. And then I need to specify, okay, what do I want to drop? Okay, I want to drop the ID column. So I'm going to say columns is going to be equal to ID, okay? And the ID should be exactly what you see over here. So capital I and then small letter D. All right, so when I do this and run this, at first you see that the ID column is dropped. The zeros and ones and whatever labeling you see over here is the original, how do you call it, indexing, okay? The ID column is actually dropped. But unfortunately, when I come back and do a preview of the ID, we see it's coming back again. So we need to do it proper, okay? And the proper thing is, okay, so I want to do id.drop, data.drop, and then the columns is going to be equal to ID this way, and then I'm going to say in place is equal to true. So adding this attribute will make sure that, look, it is actually destructive. You are dropping it. So when I run this, now everything looks good. And then when I do a preview of data, I definitely see that the ID is dropped. So now that the ID is dropped, I want to also make sure that I do the splitting so that I get my X input and then my Y output. So in order to get that, what I'm going to do is I'm going to do this. And this is what I was trying to tell you the other time. Okay, if let's say I just want to slice a piece of this, I can use this slicing technique. So I'll type in the data structure, which is the object data over here, and then bring in the square brackets, and then maybe I can pass in whatever thing I want to slice out. So if I want to slice out just this one, okay, the sepal length, I can do this. So anytime I run it, it's only the sepal length showing up over here, okay? And then we can actually verify this. So the first one is 5.1, 4.9, and then 4.7, and then we see 5.1, 4.9, 4.7. All right. What about if I want to slice maybe 2? Okay, so the sepal length and then the sepal width. So let me copy this, and then let me do a comma, and also put this over here. But then there's going to be a little issue. So when I run this, anytime it runs and runs and runs, and then you see that definitely we have an error over here. And that error is simply because of how things are being sliced. Now, when you are slicing more than one item, okay, in this particular case, we have more than one. We need to, first of all, the first square bracket is to tell that, look, this is the slicing that we want. And then the second bracket is to also indicate that whatever thing we have over here is more or less like a list. So we put a list inside of that square bracket in order for this to work. So when I run this, you see that everything has now been sliced and everything is looking good. However, if I come back and do a preview of data, remember the data is original thing, so it's going to contain everything, okay? So unless I do a little bit more to it. But then let me just continue with the other things I want to slice. So I want to slice this as well. So I'll do a comma and then paste this. And then the final thing that I want to slice is what I have over here, the petal width CM. So I'll also paste this over here. So after doing this slice, what I want to do is I want to label this. So I'm going to call this X input. So these are my input side of things. So I'll run this, and then anytime I do maybe X underscore inputs, now this is exactly what I have. Okay, all right, data is still there. I can still grab data and then work with data. Let's do same for the Y. So for the Y, all that I need is Y underscore output, and that's going to be equal to data. And then I want to slice and then get, what do I want to get? I want to get species, because that's only going to be the Y. So I'll copy this and then I'll paste it over here. So when I run this, and then I want to do a preview of my Y output and do this is exactly what we have. Okay, all right, so this is we accomplishing the first task we have over here. Okay, so we are splitting each sample into some input feature and then the output, which is the target. Now you move on to the next one. Now this time around we are doing a horizontal split, and this horizontal split is very important because we want to get a part of the data we are going to use for training, and then a part we are going to use for testing and evaluation, and we are going to see exactly that in action. But before we do so, one of the things you should understand when you are working with machine learning and stuff like that is the fact that, look, it is better to have all your inputs represented in numbers. And when I say all your input represented in numbers, this is what I mean. Remember, earlier on, we made the point that, look, when you are dealing with neural networks, okay, when you are dealing with neural networks, the computation that is done in terms of what we see over here, this output Y is equal to F of the summation of X I W I, okay, starting from I and then ending at N. All that we are trying to say is, look, it is going to be a computation of this. So in this particular instance where we are picking up the first row, okay, remember what I said, the width, which is W, is going to be randomly generated, and we are going to see the random generation from what we are going to build over here. So these are going to be randomly generated, W1, W2, and then W3. However, the inputs X1, X2, X3 is what we are going to provide. In our particular case, the X1, X2, X3 is going to be represented by sepal length, sepal width, petal length, and petal width. If you have 10 inputs, we are going to represent them by X1, X2, X2, all the way to X10. All right. Now, what happens over here, based on what we know, is that, look, when these red ones, which is the randomly generated weights, gets multiplied with the input. So you see that the first one, the instance, the input over here is 2. So that's why we see 2 times a randomly generated weight we have in red. And then the second one, we have 12, okay, which is the input 12 multiplying a randomly generated weight we have over here. And it can be negative, positive. Once it is randomly generated, it is randomly generated. And then the height 2, we get this over here, okay. Now, when we calculate this, what is happening is, this is the Y output. Now, this Y output needs to be compared with the target that we have over here, okay. The Y is going to be an output, so this is the output. We need to compare it. Is this equal to this? Over here, when we do the calculation, it is not. Look, remember what we are saying. We are learning. We want to learn and make sure that, look, when I calculate this, it is giving me this. But then when I calculated this based on the random weights, it is giving me something less. So I do a deduction. So it's going to be an error. And it's going to be the target, which is 1, minus the output I'm getting. So over here we get an error of 0.7. Now that error of 0.7 needs to be propagated back into the network, and that's going to lead to the adjusting of the weight. Remember, the inputs are going to be constant, but it is the weight that needs to be adjusted. These are random weights I picked. There's a possibility of picking some random weights that will eventually lead this into getting something closer to 1, and the error is going to be very minimal. It is this accumulative error that we are going to sum up at the end of the day to even tell that, oh, the system is learning well or not. The most important thing is the random weights generation that we do not have so much control of. Even if we have control of, it is going to be not a good thing to even do, that we are controlling the weights. We want the system to learn on its own, okay? All right. Now, the reason we need these output to be some values is the fact that we are doing a subtraction over here. So over here, if we don't change this into some values, then what is going to happen is, look, we are going to have this value multiplied by some random weight plus this value multiplied by some random weight plus this value multiplied and this one, and then we get maybe 2.5. okay, so we are getting 2.5 as our output, but then maybe our target is Iris Etosa. How do we do Iris Etosa minus 2.5? That's not going to work because this is a string, and then the 2.5 is going to be a float. So what we need to do is to now change the output we have over here into some categorical data. When we say categorical data, what we mean is we want to change it into some value. So for instance, if it is Iris Etosa, I want to represent it with a number, let's say 0. The other one will be a number 1. The other one will be a number 2, and stuff like that. Now, this is what I had to explain the other time. That yes, we are playing a World Cup. So let's say we have the countries, okay, who are participating in this World Cup, and want to build a system for that. The countries by default is going to show up as Ghana, okay. Let's do SA for South Africa. Let's do Egypt for our brothers in the north of the continent, and then let's do something like Nigeria didn't go, but then let's add Nigeria. We love them. So we have this over here. Now, if I want to get some categorical input, okay, all that I need to do is, okay, so maybe for all Ghanas, I'm going to represent it with a 0. All SA, I'm going to represent it with a 1. And I'm starting with 0 because the Python counting, indexing starts from 0. And then I'm going to go to 2, and then I'll go to 3 over here. Now, what is happening is Python looks at things a little bit different. In as much as it's going to give you this indexing as you want, okay, in terms of the categorical input, what is going to happen is it is going to look at it and look at it in alphabetical order, okay. So over here, in terms of alphabetical order, Egypt will come first because E comes before any of the alphabet we see over here. So E will now pick up 0, okay, and then I think after E, J will be the value 1, and then maybe S, maybe IJKMNOPQRSTUVW. Okay, so then N will be number 2, and then S will be number 3. Okay, something like that. Now, how do we get that? So this is going to be like the default one, but then based on the alphabetical input, this is what we are going to have. So let's assume there's another Ghana. If there's another Ghana, then because Ghana already has a value of 1 over here, this is also going to be seen as 1 within the system. Okay, so this is what I did, and then I said, okay, in order to get this working, okay, we need to do some encoding, and we don't have to do it manually. Imagine the countries represented, there are over 40 something. Is that okay? And if you have to go through manually check, all that we need is, look, let's have the countries or the data that we are working with, and then let a library do the heavy lifting for us. So the library we need over here is scikit-learn. Okay, so I'm going to say from sklearn.preprocessing, I want to import label encoder. So I'll run this, and then it is done. So what I want to do is, okay, I want to encode the country. So I'm going to say country, and this can be any variable name, okay, but I'm just using one that is descriptive. So I'm saying country encoded is going to be equal to the label encoder class I have over here. So I'll just copy this and then paste this over here, and then I'll instantiate it with this parenthesis. I'll run this. Now everything is looking good. When I do country encoder dots, and this time around, I'm going to say, or I'm going to use the fit transform method in there. So country encoder dot fit transform. What do I want to fit and transform? I want to fit and transform what I have over here as countries. So I'll pass in countries over here, and it's going to work it out. I mean, it's magic for me. So when I run this, you see that I get to see the 13021, just as I have manually done over here. Okay, so this is what we want to do, so that when we do a calculation and we end up with a 0.2, that 0.2 can now be checked or subtracted with the number I have over here. All right, so with that said, let's come in here. So we want to encode the data we have over here. So I'm going to say from sklearn.preprocessing, I want to import the label encoder I did in there. So label, I need L over here. Okay, so let me create a couple of cells beneath here. So what I need is I'm going to say Y encoded is going to be equal to the label encoder class, and then I'm going to instantiate it, and then I'm going to have the Y encoded. So Control C, Control V dot the fit transform you just saw me do. So fit transform, and then what I need is the Y output, which is originally some string input. Okay, so I'll paste it over here, and then I want to save it back into the variable Y output. So Y output is going to be equal to this. So when I run this, everything is looking good. Initially, when I ran Y output, I was getting this iris setosa, iris vesicle, and stuff like that. But now when I run this, because I've done the encoding into some categorical inputs, I get 0. So now what is happening is 0 is going to represent what we see over here, iris setosa. Okay, and the 111 we have over here is going to represent the one we saw in there, which was the iris vesicular. Okay, let me go up the previews. All right, so we saw iris vesicular in there. That was the second class, and then the third class is going to be represented by 2222. That's what we see over here. So this one is looking good. So that's exactly what we've done over here. We are changing the target output into some categorical data that we have over here. Now the next thing for us to do is now to split the data into a training part and then the testing part. And this part is very important. So I'm going to spend a little bit more time over here. So in order to do the splitting, once again, we don't have to manually do it. We can just rely on some library to do the heavy lifting for us. So this is what is happening. This is our data set. Okay, so let's let me clear this, and then let me try and see if I can get more tools over here. No, you just let me use this. So let me use the red. So I'm assuming this is our data. Okay, we've already done this split, and then we know that we have the X over here and then the Y. So you have the input and then the output, and everything is looking good. Okay, so in our case, we have sepal length, sepal width, petal length, petal width, and then we have the Y, which we have now changed into some Y 1, 0, and 2. Now what is happening here is, look, we are going to split our data into 2. So the split is going to be this horizontal split. So let's say I do this split. Kindly bear with me, okay? Oh, yes. So I do this split over here. So we are basically going to have 4 quadrants or 4 parts. So this is going to be part 1, part 2. Let's call this part 3, and then let's call this part 4. All right. Now, part 1, 2, 3, and 4, I don't think is descriptive enough. So let's give it proper names. Now, we are going to call this whole section. That is going to be the part we are going to use to train our model. So this is the part we are going to use to train our model. And then the one under here is going to be the part we are going to use to test the model. So after training, we want to test if actually the learning was done properly. Typically, we use about 70% to do the training, and then we will use the rest of it, which is the 30%, to do the testing. Now, this is not like a one size fits all. Some people will end up using maybe 80% to do the training, and then 20% to do the testing. But then it lies between that range, okay? Now, what is happening is we are going to call this session or this quadrant 1. We are going to call this X train because it is the X input and then the training part of our data set. And we are going to call quadrant 2 our Y train. So this part is going to be Y train. And then we are going to have X test and then Y test. This one kind of makes sense. So what is going to happen is we are going to use the training bits. So let me use a different marker color over here. So let me use black. So we are going to use this to do the training. And when we train, at the end of the day, we get a model. And that model is going to be that rule. It is going to be a software. Is that okay? That's going to give us the logic. So we are going to get this model. And it is out of this model, we are going to use the X test to now do some testing. So after doing the training, we'll come and deploy this and use the X test to do a testing. So we are going to feed this into this. I think, let me bring this back here so that it looks a little bit clean. So we are going to do the training. Okay, so let's bring this training and then we are going to get some model. And what we are going to do is after that training, we are going to feed the testing data into the model to actually see if things were done properly. Now, the testing is going to help us. When we feed this into the model, we are going to do what we call predictions. So we are going to do some predictions. So predict. Now, the predictions that we are going to do are going to be some values. And those values we are going to use to check if, because look, we are predicting at least the Y component. And then whatever values that we have is what we are going to use to check. So we are going to do a checksum. That look, when we train the model, we got some software, we are using it to predict. And then we put the test data in. So whatever thing we predicted, is it exactly what we have over here? Because this is going to be the actual, and then this is going to be some prediction. So these are the things that we are going to work with, okay? And these were basically what I was trying to illustrate. I think I have to clean these ones. These were the things I was trying to illustrate, especially within the confines of how we're working. So when we go through this, we see that we are getting the training part and then the testing part. And then we use the training part, the X train and the Y train, to train the machine learning model to get some train model. And then we use the X test, we'll feed it into the model, and then we are going to get some predictions. And then we are going to use the prediction to juxtapose and check if indeed the prediction was right. So that's going to be part of the analysis. So let's do the splitting. So over here with the splitting, we also have some help. So I'm going to say from sklearn dot model underscore selection. I want to import train underscore test underscore split. Nobody should tell you what this is actually going to do. Okay, this method is going to help us do the splitting. So now that this is imported, what I want is, okay, I want to use the train test split. So I'll do Control C, Control V. And the question is, what do I want to split over here? I want to split the X input, okay? And the X input is what I had already prepared over here. This one, X input. And then I also want to split the Y output. So I'll do X input over here, comma Y underscore output. And then I'll specify the ratio. So the test size, I want to specify a test size of, let's say, 0.2, which is 20%, okay? So that automatically the training size will be a 0.8. So after this is done, what I want to do is I want to decompose this into something. So I'm going to do is equal to, okay, so this is what I want. I want to have X train, comma, Y train, then I have X test, comma, Y test. So this is what is happening. Look, if you are confused about this, knows that these are the 4 quadrants we spoke about. And then it is a train test split. So the training will come before the testing. So the training side of the data will come first. So X train and then Y train. Then the testing side of the data will come first. X test and then Y test. This is, I wish we were in class because I need to be opening and closing this. Remember what we did? Okay. This was the X and this was the Y. And then we split it like this. And then we are saying that we are using the first one over here as the training. And then this one is going to be the test. So this one is going to be the test. So this is X train, and that's what we are decomposing over here. And this is Y train, that's what we have over here. And then we are seeing that the X test is what we see over here. And then the Y test is what we are going to see over here. And we have been able to do this split because we are using the train test splits. We have specified the actual data. The actual data was the X input and then the Y output. And we also specified the ratio in which we wanted to split. So everything is looking good. Let's move on. So I haven't run this cell. So now let me run this cell. When I run this, everything is okay. The moment, for instance, maybe you have a mistake and then you run, you are going to be prompted, okay? So now let's do a preview of our X train. When I run this, I see these showing up over here. This is very significant. It is very significant in the sense that, look, earlier on when we were dealing with doing a preview of the X data and the Y data and stuff like that, look, we saw that the order in which the data was presented to us was very key. So you saw that from the indexing count column, okay, we see that it was starting with 0, 1, 2, 3, all the way down to whatever thing it was supposed to do. Now, when we use the train test split to do the splitting, and we are doing a preview of X train, we clearly see that, look, things have been randomized over here. So this is the 101th row, and then the next one is 78th row, and then things have been shipped or messed up over here. And we can clearly see that we have 120 rows by 4 columns. Why 120? Remember, this is the X train, and this is taking about 80%. So if I'm to do 0.8 multiply by the original size, which was 120, I'm getting which was 150, I'm getting 120 over here. So that's why we are left with 120. And then the other 20%, if I'm to do 20% times 150, I'm going to get 30. So the testing size is going to be 30. All right. So let's see that. So I'm going to do X test. When I do X test, let me see. Sorry. I think the manner in which I put things up over here is going to mess things up. X test. No, X train. Oh, sorry. Okay, let me try and look at this properly. So X tests. Let me see. X test. And if I'm to do dot shape over here, we are getting 120. So X train, X test. This doesn't look good. Let me see. And I always do this as my reference, okay? So this is my 30%. In this case, I'm using 20%. So this is my 20% and this is my 80%. And this is my training. So I'm saying that this is X train. So X train is looking good. Then what about X test? X test should be the 30% of the data that I have over here. So this should be X train, and then this, what I have over here should be. Oh, okay. So this is so this should be Y train, but what am I seeing? X test. Okay. No. So let me try and preview Y train. Y train is supposed to give me the zeros and ones because that's the Y and the training. So that should be give me this one. So I think I've messed up with the names. Very good. I've messed up with the names, and eventually this was going to give us some problems. Okay, so this Y train is supposed to be the Y test. Okay, so this this is supposed to be, let me cut this over here. So let me do, this is, so X train, X test, then Y underscore train, then Y test. Let me try this and see if I'll get exactly what I'm looking for. So let me start running it from this side, and then let's do this. So this is X train, okay, and this is Y train. No, Y train cannot give us this. Y train should give us the numbers. X train, Y train. Why am I getting confused about this? X train. Okay, so X, my training should come before my testing. That's basically what I remember about this. So Y train, and then X train. Sorry, Y train, Y test. So X train, Y train, X test, Y test, I think this is what I'm missing. X test, Y test. So this is what it should be. So all your training should come first, and then all your testing should follow. So X train, Y train. So this quadrant, X test, Y test. Good. I think this is what I was messing up with. So X train is what I have over here, and then Y train. Why is Y train giving me this? Y train should give me the zeros and ones, because that's what I expect to see over here. So Y train, if, okay, okay, so X train, X test, then this one is supposed to be Y train, Y test. Okay, so let me do this. So this is, so I think this is what I need. Okay, so the X train, that's what I see over here. So the X train is going to be the zeros, the numbers we see over here. And remember, we changed the how do you call it, the Y train to be some categorical zeros and ones. Okay, so that's what we see over here, the Y train, some zeros and ones. And then if I'm to do a dot shape over here, I'm going to get 120 of them, and then the rows for X train is also going to be 120. All right, and then when I do X test, so X underscore test, remember X test is supposed to give me the number sepal length, sepal width. Okay, that's what I see over here, and that's going to be the shape of this is going to be I think 30. So if I'm to do the shape over here, I'm getting 30 by 4. Okay, that's good. And then let me do the X test. Sorry, this X train, X test. Okay, then let me do Y test. So Y test is also giving me this. Okay, so now everything is looking good. This is exactly what I wanted. But then again, things have been randomized over here. Okay, so now that we have this, now let's look at how we build a network that looks like this. And in order to also visualize some of these things, this is a tool I'll highly recommend. Maybe you use, and then you see a few things. So over here, let me see ANN network diagram. Let me see. Okay, visualize. No. ANN network visualization. So let's see if my network will do me any good. If it is taking more time than necessary, we'll just skip that part and then we'll move on. Okay, so now you are going to build a network. So the network, you are going to use Keras. So I'm going to say from keras.models, I want to import sequential. And then from keras.layers, I want to import the dense layer. So I'll run this. Now, what is happening over here is Keras is from TensorFlow, okay? And TensorFlow is a Google library, basically developed by Google. And then what they do is they have the most advanced development of these ANN, okay, or artificial neural network models. And what you can do is we are going to build a model that looks kind of like this, okay? So the layers are going to be, or the model is going to be in some sequential order. So there's going to be an input layer, a hidden layer, and then an output layer, something like that. And then we are going to have the layers, how we are going to stack things up. We are going to use what we call the dense layer. So you see that with this particular layer, the neurons are stacked next to it, or on top of each other. So we refer to them as dense. Now, after these imports, we need to build a model. So I'm going to say model is going to be equal to sequential, this way. So by doing this, what I've done is I've created what I call the skeleton of the model. Okay, this is the skeleton of the model. So I'll run this. And then I need to start adding the layers. So I'm going to do model.add. And what do I want to add? I want to add a dense layer. And that dense layer, there are some few things we need to ask ourselves. Okay, so how is the data structured? The data is structured in such a way that it has 4 inputs. So we need to make sure that the layer has 4 neurons. So I'm going to say 4 neurons over here. And then I need to specify an input shape. What is the shape? How does it come in? So I'm going to say input underscore shape. And then I'm going to say 4, comma. I'll explain what I mean by this 4, comma over here. Okay. Then the next thing I need is an activation function. So I'll say activation, and then I'm going to say relu. All right. Now we cannot cover the entirety of the details of everything over here. I'm going to tell you what it means, and then when we meet in class, we can probably have a conversation and look at the various activation functions and what they mean. But let me start off with explaining what I have as the input shape over here. And with this one, kindly bear with me. So look, with the data that we have over here, so let's take for instance xtrain. Okay, so if I'm to take xtrain, so xtrain, when I do a preview, I'm getting this. Now if I want to select what I have from the index 6, the index 6, I cannot do a slicing of it just like that. Okay, so there's a method over here, and kindly pay attention to the numbers we see. So we see 4.6, 3.4, 1.4, and then 0.3. All right, so when I do dots, and then there's an ilock method. Okay, and then I pass in the value 6. That means I want to grab what I have on this particular row. So when I run this, I get the values that we saw over there. All right, now remember, it is this format that we are going to feed the data into the model. Remember, we are saying that we have 4 neurons, something like this. 1, 2, 3, 4. Okay, this one is 5, but then we have 4. Okay, and this 4, so this is going to be like the input neuron. So 1, 2, 3, 4, and every x1, x2, x3, x4 is going to represent the various sepal length, sepal width, and all the how do you call it, the inputs we have. So what is going to happen is this one, for instance, is going to represent x1. Then this one is going to represent x2. Then the third one, x3, and then the final one, x4. So these values are going to be x. Weights are going to be randomly generated. We are going to see them very soon. Now, when they come in, they need to come in as a shape of 4, 1. Because look, the way I've selected this way, if I'm to do dot shape to actually do a preview of the shape, when I run this, I see 4, What this basically means is I have 4 rows, and then I don't have anything when it comes to, technically I don't have anything when it comes to column per se, because if you don't put it out this way, then the system is going to be a little bit confused. All right, now I think what I am also missing out is the input shape is going to be equal to, okay, so the input shape is going to be equal to this, and then the activation function is going to be equal to relu. So the big question is, what is this ReLU that Mr. Bruni is talking about? This ReLU is the rectilinear activation function. There are a lot of activation functions. So what is happening is every input after doing the summation operation would fire the output. So I had it inside of the notes, but maybe when it came to the explanation, I skipped that one. So that's what happens over here. Yes. So you see that it is the summation operation that we've made mention of, but then there's a function which is going to be the activation function that's going to fire out the final thing. So now the point is, look, what will usually happen is, look, when I have this data, look, when I did the calculation, I got a 0.83. That 0.83, when I'm firing it, okay, when it is coming out for me to get the value y, I can do something to it. And that something I'll do to it will very much depend on the target I want to do some comparison with. So for instance, if the target I'm doing comparison with is something like 20, 15, 100, 300, some values that came natural, then I'll be very careful with the activation function that I'm looking at. So now look at this. If I'm to look at ReLU, and like I said, when we meet in class, we are going to deal with these things in details. This one is a rectified linear unit, okay? It's one of the most popular activation functions in deep learning. It functions as a mathematical gatekeeper for neurons, putting the input directly if it is positive and zero otherwise. So what we are trying to do is, if it is, we put the input in, okay? If it is positive, we are okay. But then if it is zero, then we keep it like how we want it. All right. And then there are some different variations of it and stuff like that. So over here, I'm trying to look out for a graph, because usually the graphs are very easier to explain with. So let me open this up. Oh, this network. All right. So this is what is happening here. So over here, we are seeing that for the rectilinear function, okay, it is going to be the f of whatever computation we've done, and it's going to pick up the maximum value between 0 or the output that we are getting. So if it is negative, it takes it as 0. But then if it is positive, then it's going to take that positive value. So it is either 0 or a positive value. And the reason why we need this is we don't want a situation where we are getting negative values from this computation, because from this computation, our targets are all positive. So if it is negative that we are comparing, then it becomes a little bit problematic. So we are using ReLU over here. Now let's add in another model. I'm going to do model.add. I'm going to put in a dense layer. This time around, I'm going to say 5 neurons, and then activation is going to be equal to, once again, let me do ReLU over here. And then finally, I'm going to do model.add. And this is going to be my output layer. So over here, something interesting is going to happen. I'm going to say dense, and I'm going to put in 3, and then activation. Activation, I'm going to put softmax. So I'm going to say softmax over here. Sorry about that. Now, what is happening here is, typically, you are at liberty to do or give the architecture of your network, do anything that you want. But you are always minded about the input layer and then the output layer. Remember, the input layer is more or less predetermined, and it's going to be predetermined because of the number of input values you are feeding into your network. So if it is 4, in the case of what we have, sepal length, sepal width, and all those things, it is 4. So we make sure that we put in 4 neurons, and then we specify an appropriate input shape to correspond with them. In the case of the output layer, that's also going to be determined by the number of classes that we have. Over here, remember, we have Iris setusa, Iris versicolor, and Iris virginica, so we are minded with that. Now, in between that, we could have, for instance, maybe added some more layers over here, okay? and stuff like that. We can do that. But then the more layers we add, then the more computational time we are putting on our system. Okay. So we don't want a situation where the network is too big and then it is taking so much time to execute. Now, the softmax is also one of the activation functions that we have. Like I said, when we meet in class, we are going to spend a lot more time in there. So now let me run this, and then we don't seem to have any problem. All right. So now we have built the network. Now, the next thing or the next activity we want to do is to check the model summary. Okay, so I can do the model dot, and I'm going to say summary. So when I do model dot summary, it gives me an idea of how this network looks like. So these are the layer types. So the first layer was a dense layer. I had the output shape of 4 over here, and then I had the first layer, okay, dense 1. This was the shape, and then these are the parameters. The parameters are basically calculating the number of weights, okay, and the computation that will be done thereof. And then we also had this, and then there's the output layer. So it gives us the total parameters and stuff like that. All right. We are going to see this with some exercise we are going to do in class later on. Now let's check the initial weight. So I'm going to do model dot get underscore weights over here. So when I do model dot get weights, like I said, the weights are going to be randomly generated. So just after specifying the architecture or the skeleton of our model, some random weight has been generated. And look at this. The first one we see over here is just 4 by 4. Okay. This is 1, 2, 3, 4 rows and then 4 columns. And it is so because of the 4 inputs you are bringing in. And remember, for each input, okay, these inputs 1, 2, 3, 4 are going to be connected by the next layer was I think 5 neurons. So you see that you have 1, 2, 3, 4, 5 over here. Now it is a massively parallel connectivity or connection. So every neuron is connected to all the ones in front of it, kind of. So what is happening is, look, this one is connected to 1, 2, 3, 4, 5. Okay. This one is also connected to 1, 2, 3, 4, 5. So all of them. So it is going to be 4 times 5 to get us 20. Okay. And that's why we are seeing that the parameters for the first side is going to be 20, because those are the synaptic weights that we see over here. And then if you do the calculation for the second one, remember the second one, we don't have a good representation over here because we see that the next layer is giving us 10 neurons, okay, in front of it. So that's going to deal with the calculation for us to get a 25, and then we get a 60 ahead and stuff like that. So over here we get the the weights randomly generated, okay, and there are going to be some values over. These are what we call the bias, okay. So these are going to be biases, and then there's another random weight generation, okay. So every layer is going to generate some random numbers for each and every particular synaptic weight or line that is connected. So now let's do a compilation of the model. So now I'm going to do model.compile, and then I'll compile with a few things, okay. So the first one I need is the optimizer, and we are going to spend a lot of time in class to explain this. So the optimizer, look, not sometimes, these systems that we run on dealing with neural networks are highly computationally expensive. What that basically means is, look, we can have a model running for 2 years without completing its work. And part of the reason is the fact that, look, it is an iterative process. So remember what I made mention over here. We are checking error, and then we'll come back. The weights will be randomly generated once again upon every iteration. Now, it could be that, look, anytime we check the error, we are still getting a 0.7 or a 0, something which is too wide. The system will continuously do that work until it gets something very minute error. We don't want that to happen. So we use an optimizer to optimize the process, okay. And this optimizer is what we call the ADAM, okay, or this is the adaptive machine learning optimizer. So we are also going to look at the ADAM optimizer. There's the adaptive machine learning. There are different types of optimizers, and it also depends on the kind of machine learning task that we want to deal with. Okay, so the optimizer, the Adam optimizer, we are going to see that there's the adaptive moment optimizer. Okay, that's the Adam, and it is highly efficient gradient based algorithm used to train deep neural networks and stuff like that. So we are going to see details of that, okay, when we meet. So after we specify the optimizer, we need to specify what we call the loss function. So the loss function over here, we are going to use something we call sparse categorical underscore cross entropy. So sparse categorical cross entropy. And if your guess is as good as mine, we kind of should have an idea where the categorical is coming from, because for our output end, we changed everything to some categorical output. Okay, so we want to make sure that, look, whatever comes out is something that is categorical enough for us to make some decision. So that's what you have over here. And then we want to measure some metrics. So we are going to specify some metrics over here, and then we are interested in accuracy. So accuracy is what we are interested in. So we do model.compile, we specify an optimizer over here, we are using Adam, and then the loss function, we are using sparse. And once again, these are the details we are going to discuss in class. Okay, there are different loss functions and stuff like that. So this time around, we are using sparse categorical cross entropy. There's categorical cross entropy and other ones, but over here we are using sparse categorical, and I'm going to explain in class when we meet. And then we are using the accuracy. So I'll run this, and now we need to fit the model. So this is where, look, all this while we haven't put in our data yet. We are just defining the architecture of the network and then the parameters we are going to use to achieve that architecture. So I'm going to do model.fit. So this is where we are going to put in the data. So what do I want to fit? I want to fit X train, okay? And then I also want to fit the Y train, because that's a training part that I want to train my model with. And then I'm going to specify an epoch. The epoch is something you probably have seen before, okay? So remember when you were dealing with the Google Teachable Machine, you saw something along the lines of epoch. I don't know, my network is not helping me at all. Let me connect to the eSkills network and then see if that will be anything good. All right. Okay, so with Google Teachable Machine, we got a feel of what the epoch is probably going to look like. And then when I click on Get Started, later on in class when we meet, we're actually going to build a model using one of these ones, okay? And then we are going to save the model, and then we are going to come back into the Jupyter Notebook to actually analyze the model and see behind the scene what was actually done for us, okay? We are going to see the architecture of the model and all that. So when you click on the image project, and then we select this one for the standard one, we get to see this. So now what you have over here, when you click on advanced, okay, when you do the training and stuff like that, you see that you have epoch over here, okay? So this is something you probably didn't pay much attention to, but then you can change the epoch and stuff like that. And then there's what we call the learning rate, okay? By default, the Adam optimizer, the learning rate is the 0.001 you see over here, okay? So when you click on this, it is a look, be careful tweaking these numbers, blah, 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 and stuff like that. All right. So the epoch is basically going to tell us, or going to tell the system, the number of iterations that you want. You see over here, because you are just clicking and just playing with the buttons over here, all these things were done for you. It's because we are doing it from scratch. That's why we need to spend time to specify the optimizer, the loss function, and all these things. So the epoch, let's say we put 50 over here, okay? And the inspiration is, okay, there's 50 over here, so let's put 50. Now, like I said, the epoch is going to specify the number of iterations. So the more epoch we put in there, the more time is going to take for the computation to be done. So now that I have this, I can do a shift enter to run this. If you don't have any problem with anything that you have specified, it is going to run. But then, okay, so thankfully it is running. And you can see that upon the first iteration, going through the numbers and doing the learning, the accuracy was around 35%, okay? Then it dropped all the way to about a 10% over here. So it wasn't looking good. It came very down and then it started going up, okay? So upon about the 15th iteration out of 50, we had about 22% over here. It went up. Now we are about 45, about mid through, okay? So it is not doing that bad. But then we get to about 50% when we're about the 33rd iteration. Then it moves a little bit up. We are now heading towards good numbers over here. Now we have about 60. So you see that the learning will be done back and forth, okay? It's almost like you are learning the past question. You learn small and then you try and answer some of the questions. Okay, you get a few right, you get a few wrong. Then you go and learn again. You do that until you get to a point where you are getting a lot of the answers correct. So we get to this part and then we see that the highest we could get was about 69%. All right. So now here lies the question of, okay, so if you are writing exams and you think, look, you've learned so well that you're about 69% sure that you are going to make the pass mark. Somebody will say, okay, me, I'm fine. 69, actually, I've done too well. Another person will be like, no, I want to do better, okay, because I'm looking at my GPA and stuff like that, okay? So it depends on the kind of problem you are solving. Look, if you are solving or you are building systems for the medical field where there are serious consequences to a wrong diagnosis, you don't want to be settling down for 69. You want to go into the 90s, okay, 95%, stuff like that. So let's train this one more time. And then this time around, I believe the training is going to be much better. But then, okay, we are in about 80% over here. It moves. And then we ended up at 80. So the highest we could go was 80. So let's train it one more time. And then if we get anything better than 80, at least that'll be good. I also don't want us to get something that is too perfect, okay, because of the analysis that we are going to do thereof, okay? So maybe for shaggy reasons, let's leave it like this, 80. Maybe in class or maybe when you do yours, you are probably going to get different values depending on how efficient your system is and stuff like that. But then I'm okay with 80, not because it is the best, but it is because I want to have issues with, because it is 80%, we are getting some wrong predictions and stuff like that, and that's going to help or enrich our analysis. Now, you don't expect to get 80 and be like you're okay, no. But then what is happening over here is, look, I could be running this over and over again, and maybe in a matter of seconds or maybe a minute, the compilation is done. However, in the case of real world projects, you are dealing with large volumes of data. Probably running it one is going to take about 2 hours, 3 hours, 10 hours. So it is not like for the fun of it, I ran in the first one, I want to run again. Some can take days. Okay? So we just have to have that trade-off. But then I'm okay with this. So over here, I can check the final weight. So I can do model.get_weight over here. So when I do model.getWeight, I'm getting this. Now, this is the final weight. Now, remember initially we checked the weights before, okay? The first randomly generated one. Over here, we are seeing a negative 0.181. If you have to go through this, when the weight was first generated, okay, this was the first initial weight, we got a negative 0.181. And then we are still getting, for the first one, you are getting negative 181. Let's try and see if we are going to get something different from some of the other weights. So the second one we have over here is 0.67. Let's check this one. We are getting good. So this one changed a little bit, okay? So it was from 0.49 to a 0.67. So you see that the weights were changing, okay, upon every iteration, but we cannot see it one by one. We can get the initial weight once the parameters were determined, okay, and built up, and then we can get the final weight over here. So now we can do a plotting of the accuracy and stuff like that. Okay, and that's going to be in the next video that I'm going to do. So this is going to be the first part where we have built the model and then we have seen a few things, and then we are going to see how we do the analysis and then make predictions thereof. Thank you very much.